We now turn our attention to the consensus problem, and in particular, single value consensus. In consensus, processes propose values, and they all have to agree on one of these values. That's why we are talking about single value consensus. Solving consensus in general, and not only a single value, but also if we have consensus of sequences of values, is a key for solving many problems in distributed computing, like total order broadcast, which sometimes called also atomic broadcast, atomic commit in databases, terminating reliable broadcasts where processes know that a broadcast have been terminated, and dynamic group membership where the number and the identity of processes in a group can change over time, and they have to agree who is in the group and who is not, and stronger shared memory models, where you have objects that not only support read and write, but also supports other primitive like compare and swap, or you have queues with different operations like enqueue and dequeue, and many others of this type. So what is single value consensus? We have our safety and liveness property. So the first property is validity, which says any value decided is a value that is proposed by one of the processes. Second, we have agreement, and in this case we say no two correct processes or nodes decide differently, and we are talking about correct nodes or processes, so we are talking about regular consensus. Then we have termination, which say that every correct node eventually decides, and integrity, which say that a node decides only at most once. So just observe that in this case we are talking about a regular consensus because we are saying that the agreement is between correct processes only. So here is a sample execution where we have three processes, P1, P2, and P3. P1 proposes the value 0, P2 proposes the value 1, and P3 proposes the value 0. P2 decides on the value 1 and then crashes. P1 decides on the value 0, and P3 decides on the value 0. So does this satisfy consensus? And the answer is yes, because in regular consensus, we do not care about crashed processes. We can change our definition slightly, so we have the same validity, termination, and integrity, but we change the agreement to be uniform agreement, which says no two nodes decide differently, and in this case, whether they failed or not. So here is a sample execution, the one that we had before, and of course, this one does not satisfy uniform consensus because P2 decide differently.